So what we're going to do today is we're going to start chapter 7, section 9, which is going to be completely factoring polynomials. We have 3 learning targets, the first of which is that you can use those to solve real life problems. Hopefully we'll get to that today. This 13th and 14th of the chapter is that you can use the box method or the grouping method of factoring. And then lastly, that you can factor and solve polynomials completely, which means you're going to take a polynomial, you're going to factor it, and then you might have to factor it again in order to get the answer that you want. Okay. Let's move on to this box method of factoring. Okay. So much like other methods of factoring polynomials with 4 terms can be done by placing the terms into groups, which is the grouping method, and factoring them using the greatest common factor. Okay, in this class, though, we typically have been using the box method. Notice that it's not the X box method, but just the box. They're very, very similar. It's actually just one less step. You don't have to fill out the X. Okay. In order for the box method to work, what you need to do is you need to ensure that the B value divided by the A value is proportional or equivalent to the D value divided by the C value. Okay. If those proportions hold true, okay, they are going to be equivalent to each other. And it's just going to be in your standard form in that order, A, B, C, D. So A, B, C, D. Okay, so here I can check 3x squared divided by x cubed. Squared divided by x cubed. Okay, if I were to simplify this down to see if it's going to be proportional to D over C, I would have 3 times x over x times x times x. We have common factors of x on the top and the bottom. In fact, we have 2 pairs of that. And so we're going to be left with 3 divided by x. So the B value divided by the A value is equivalent to 3 divided by x. So we just have to check, does D divided by C equal the same thing? If it does, we're going to be able to use the box method. Okay. If it doesn't, we'll have other methods for that. Honestly, in algebra 2, not in this class. Most of yours are going to follow this pattern. Okay. D divided by C, which would just be 6 divided by 2x. D value divided by C value. Okay. Then here I could split that 6 up into 2 times 3. And then the bottom would just be 2x. We have common factors of 2x that would cancel. And we get 3x. Okay. So the B value divided by the A is proportional to the D value divided by the C value because they both equal 3 divided by x. Okay. What does this mean? It means yes, they're equal. When yes, they are equal, that informs us to use the box method. Okay. Notice not X box method, just regular box method. And for the most part, we should have a pretty good idea of how this works. Okay, there's 4 terms. There's 4 squares. Each term is going to get a square, typically A, B, C, D. How do you find the outsides? The exact same way that you found the outsides, like when we do the X box. It's basically the same method. It's just starting it off is different. What do I look for? How do I find these sides? The greatest common factor. Good. So here, what is the greatest common factor between 3x squared and 6? 3. Good. And if you recall from last time, really, and actually it wasn't last time, it was like 2 times ago. But once you find that first part, it kind of unlocks the rest because you can just problem solve. Like you don't have to know what the greatest common factor between these is. Because I know 3 times this needs to give me 6. So what does this have to be? 2. Got to be multiplied. Okay, and if this is 2, what do I have to multiply 2 by? Become 2x. X. And then here, what do I have to multiply x by to become x cubed? 1x? X squared, because x times x is x squared. So x times x squared is x cubed. Okay, and so what does this factor into? It factors into x plus 3 times x squared plus 2. All right. That's what the box method looks like. Any questions about that? Very similar. Okay. Let's go ahead and do 1B where it's more variables than not. It seems like it'd be a lot tougher, but it's not too bad. I'm going to check the B over A equal to D over C, but just for this, the sake of this class, that's always going to be proportional. Because the other 4-term method of factoring we're not going to cover in this class. So though I'm going to cover it right now, honestly, if it's got 4 terms, you can just jump right into the box method. Okay, so B over A, is it proportional to D over C? B over A, x over x squared. Okay, so if I have x over x squared, how many more x's are on the denominator or on the bottom compared to the top? 1. So this is what it's going to simplify into. Just 1 x left over on the bottom, and then the top x cancel out with a 1. Now the other one, D over C, the y's would cancel, common factor of y on top and bottom, leaving a 1 left over and an x there. So they are proportional. You can use the box method. But again, all 4 terms in this class are going to be box method factoring for us. Okay, so let's set up the box. So when you do monitoring progress 2 and 3, or 1 and 2, I mean, you can honestly just jump right into the box method if you want to check. But I'm telling you that they will be proportional to each other. Okay, this one is a little bit trickier. It's no numbers, right? So what might be helpful is, again, getting yourself that one spot where you just feel like you know, and then just kind of problem solving the rest of the way through. So just maybe something that you feel like you really know what the greatest common factor is at. Because I'm not 100% sure you all would know. I mean, I'm sure some of you do. That one might be a little bit tougher.
Wasn't it for the x squared on the top of the x and on the side of the x?
It would be, right? Because the greatest common factor here is x, right? And we've done exactly that before. So this will be x. So if this is x, this would also have to be x, because x times x is x squared. So then now we can start figuring out this. X times what is x? 1. So this has to be 1. And then here, 1 times what gives me y? Y. And then y times x is xy, so that's perfect. So these are our factors. A little bit different looking, but not impossible. And that's a box method. Again, box method, almost the same as the X box, actually just a little bit less work, I actually feel like. Which is nice, because then at least there's a little continuity between the methods. Okay, any questions about A or B? All right, you know the drill, right? Monitoring progress 1 and 2, go ahead and give those a shot. I'll leave this up on the screen for you for a second. Let you work through those. And again, remember, you do not have to check if B over A is equal to D over C, because in this class, it's always going to be equal. It's just kind of starting you off with that so you have an idea. Let's go jump right into the box method.
This would be positive, everything's positive, so it's all positive. We're looking multiply by A, A. We're looking multiply by three. One.
Oh, wait. Yeah. Good job, Aaron. I know there's one. Does this go all the way right though?
I'm assuming the increase in chatter means we're ready to move on, so let's go ahead and go through these. Hey, so I just set them up. Okay, so let's, because I feel like setting them up's not difficult, right? The B over A is equal to D over C on both of them. So here, again, just find that starting point. To me, I think this is the best starting spot for me. What's the biggest number that divides out of 3 and also 3? Is it 1 or is it 3? It's 3. Okay. So, I think you were doing this one though.
Oh.
Yeah, so then here, 3 times what is 3? Well, that's our 1. Okay. What do I have to multiply 1 by for it to become A? A. What do I have to multiply A by? So it becomes A cubed. A squared. So this factors into A plus 3 times A squared plus 1. So it's, I firmly believe that these problems are all about just get yourself that starting point. And then after that, I think it gets a little bit easier. Okay, who thinks they have a starting point for 2? One spot where they feel like they know what the greatest common factor is.
Why does it Y on
In the left corner, so here. Yep, so Y is in common, so I have a Y here. And since there's a Y here, Y times Y is Y squared, so this also has to be a Y. Top's right is going to be X, because Y times X would be YX. And then what does this have to be? 2 times Y is 2Y, 2 times X is 2X, so this does have to be a 2. Okay, Y plus X times Y plus 2. Nice job. Okay. Then just get yourself started. Okay, any questions about regular box method? All right, favorite thing we do the whole year, coming on up right now. I mean, for real, I do genuinely enjoy what we're about to do. Because we've actually, okay, we actually have covered a lot of different factoring methods. Okay, and so what I have here is going to be a flow chart that's going to inform you about what method to use when. All right, because we have all these different methods. How are you supposed to know when to use them? Well, this is what it's going to be. Okay, a factorable polynomial with integer coefficients. It's factored completely when it's written as a product of unfactorable polynomials with integer coefficients. Integer means like whole number, positive or negative. Okay. To factor a polynomial completely, use the flowchart to know what methods of factoring you must use. You may need to go through the factoring flowchart more than once. Okay, so the tail ends here are the factoring methods. So we've covered all of these methods before. Okay, so following through the flow chart gets you to the method, and the method is up to you knowing how to do. Okay, so as I work through this, notice that there's one that just says algebra 2, because if the B value divided by the A value is not equal to the D divided by C, that method you're going to learn in algebra 2, which requires syntactic division, which you guys kind of have an idea of how to do. That's beyond the point. Let's just dive into it because this section took a little bit longer than previous things that we've been doing. Okay, before I begin solving these, what does it all have to equal? Okay. Has to equal 0. Does number 2a equal 0? What's it equal then? It does equal 0. Okay, and so this is what you're going to do. You're always going to start right up in here in the flow chart. Okay, right here. And the first thing that you're going to do every single time, actually, before we're going to do that, I forgot we have a typo here. We're going to change that 6 to a 3 in the middle. Good thing I caught myself. This is going to be, yep, this is going to be a 3. Okay. Here's the first thing you're going to do every single time, and that says what? Always take out GCF. Okay. Greatest common factor. That's the first thing you want to check for every single time. So as I check through this, I'm going to ask myself, is there a greatest common factor?
Yes.
What's the greatest common factor? Okay. Okay. Okay, remember, sometimes our greatest common factor is going to have a variable in it as well. Okay, is there a variable that divides out of all of these?
X.
X. Okay, so here's x cubed, x times x times x. Here's x squared, x times x, and here's just regular x, right? So when you're taking out the greatest common factor with the variable, you want to ask yourself, what's the most amount I can take out of every group? Well, I can take out 1, 1, and 1. I can't take out 2 because there's only 1 here for me to take out. Okay, so I'm dividing out of 3x. Okay. If I take 3x cubed and I divide 3x out, 3 divided by 3 is? What is 3 divided by 3?
1.
What about x cubed, but I divide that 1x away? What's left over?
X squared.
X squared. Okay, I take 3 divided by 3. Okay, and I have x squared, and I'm dividing 1x away. Negative 18, and I divide it by 3. Negative 6. Okay, x, and I divide that x away. There's no x's left over. All right, that's what taking out the greatest common factor looks like. Okay, is there any questions? Okay, hey, how I'm going to grade you is I believe if you can take the greatest common factor out, that's a method of factoring. That's your half credit. Okay. Are we sure we're good here? Okay, so now what we're going to do is we're going to see whether this can be factored further. So I'm going to look at this part here inside the parentheses, and I'm going to continue to follow the flow chart. Okay, so I took out the greatest common factor. The next thing I'm going to do is ask myself, how many terms do I have? So inside this parentheses, how many terms do I have? 3. Okay, when I have 3 terms, the first thing I want to check, is that a special pattern or not? This is how you check, because we went over the special patterns last class. Is the first term perfect square? 1x squared. Yes, it is. Is 6 a perfect square? Look up on the board. We have the list of squares. It's not one of them. So is this a special pattern then? No, it's not. Neither of them are perfect squares. Okay, so instead of going to yes, we're going to no. Okay. Then ax squared plus bx plus c. Does my a value equal 1? Yes, it does. What method of factoring do I have to do? Regular x method of factoring. Okay. What number goes on the bottom here? A times C. Good. Am I going to use 3 and 18 or 1 and 6? Going to use the 1 and the 6, so negative 6. And the B value? Positive 1. Okay, what kind of numbers am I going to have? If I'm multiplying to negative 6 and adding to 1.
Was it 1 positive, 1 negative?
1 positive, 1 negative? 1 positive, 1 negative, multiply to negative 6, add to positive 1.
5 and 1.
5 and 1 is going to multiply to 5. We got to multiply to 6.
Oh, 6.
5 and 6. No.
5 and 6 multiplies to 30. 1 and 5 multiplies to 5. We want to multiply to 6.
1 and negative.
1 and negative 6 would multiply.
3.
It's going to be 2 and 3, positive 2, Positive 3. Those who are saying 1 and 5, remember it's got to multiply 6. Okay. Okay, so then this factors into 3x times x plus 3 times x minus 2. All right. So now the only thing that's really throwing me off is this last sentence up here. You may need to go through the flow chart more than once. How can I tell if I have to go back and check again to see if these can be factored further? Okay, and the answer is going to be pretty simple. Okay, I want to make sure everybody listens because we're going to get to this point in every problem and I'm going to ask the same thing. I do not have to go back through the flow chart because I have no higher degrees. I don't have an x squared or an x cubed or an x to the 4th or 5th power. I just have all x to the 1st powers. That's a pretty good indicator that this is factored completely. So do I have to go through the flow chart again? No, because these are all factored completely because the degrees are 1. All right, how does this help me solve? I got it set equal to 0. I factored it. Now what? How do I actually find my x values? This has been consistent since 7.5. Same method over and over and over again. Why did I set it equal to 0 in the first place? How come that was a thing we wanted to make sure it was true? Why did I set this? Why did I want to make sure it was set equal to 0 right off the bat? And then factor. We already factored. How do I find my answers? 3x times x plus 3 times x minus 2 equals 0. Fine. We've done this exact same thing in 7.5, 7.6, 7.7, 7.8. We spent 2 days on each of those. That's 6 days in a row of doing the same thing. Why is this set equal to 0? All my other classes were able to answer this. You guys can too. Okay, start looking through your previous page of notes. Look at the ones where we're solving. Why was this set equal to 0? What does that allow me to do? The what?
So A and B.
0 product property. What's the 0 product property say?
A times B equals 0, then A equals 0, or B equals 0.
Okay, so if I have one number times a second number times a third number, my result is 0. What do I know about any one of these third numbers?
A equals 0.
They equal 0. So I can set every single one of them equal to 0. Zero product property says if I have a string of things multiplied together, my answer is 0. Any one of those are going to have to be equal to 0. So that's why we set it equal to 0 in the first place. Okay. How do I solve 3x equals 0? What do I do? Divide by 3. 0 divided by 3 is 0. First answer is 0. X plus 3 equals 0. How do I solve that? Minus 3. 0 minus 3 is negative 3. X minus 2 equals 0. How do I solve that? Add 2. And those are my 3 answers, okay? I have 3 solutions here. Okay. All right. 2B. First thing you want to ensure is that this thing is set equal to 0. Is it set equal to 0?
Yes.
Yes, it is. Okay, so now what I'm gonna do is I'm gonna start up here. And the first part of factoring is what?
Make sure it equals 0.
Okay, and so then we already did that, and so now the greatest common factor. Is there a greatest common factor between 7x to the fourth minus 28x squared?
7.
Okay, 7. Let's check for variable. Okay, this is x to the fourth. This is x to the second. What's the most amount of x's I can take out of each group? 2 of them.
One.
I got 2 x's here. I can take out and 2x, and I got 4 here, so I can take 2 of them out.
Oh, the other one first.
Not 2x.
Or x squared.
X squared, good. Okay. So 7 divided by 7 is
1.
1, x to the fourth, and I divide x squared away. What's left over? X squared, 1x squared. Okay, negative 28 divided by 7,
4.
negative 4, x squared, and I divided them away, is just negative 4. Okay, that's greatest common factor. Okay, how many terms do I have? 2. You only check inside the parentheses. You're going to check for special patterns. A squared minus b squared. Okay, is the first term a perfect square? Last term a perfect square?
Yeah.
Well, is it yes or is it no?
Sure.
It is. 4 is a perfect square. Am I subtracting? Okay, so this is going to be that difference of squares formula from last class. What do I have to multiply by itself to get x squared? What do I have to multiply by itself to get 4? So what's my a value? What's my b value? What's it factor into though? My a value is x and my b value is 2. What does it factor into? Just 2? So 2 times 2 is x squared minus 4?
1.
X plus 2? That's part of it, but not the whole thing. Go back, look at difference of squares formula in 7.8. Nope, close on. 7.8, difference of squares.
Gonna be, x, x minus 2 times x plus.
Yep. Yeah, this is gonna factor into that a plus b times a minus b formula. Or special pattern. That's the 2-term one. Okay. Hey, same question that I just told you I was gonna ask you on the previous example. How do I know if I have to factor again? What's an indicator that I might have to?
If they're all on first square.
Not quite. You're close. Like if you see an x squared, and I have an x squared here, right? Okay, the only problem is if I go back up to the flow chart, when we go to how many terms there are, is there any 1 terms? No, there's not. There's only 2 terms. And this is a 1-term expression. So we're good to go. This is just factored. Okay. What do I do once everything's factored? Zero product property, which says set them all equal to 0. I gotta think about how I'm gonna solve this. So 7x squared equals 0, divide by 7, again, x squared equals 0. If x squared equals 0, what do I have to multiply by itself? And my answer be 0. X times x is x squared.
0.
0 times 0 is 0. So the x would have to be 0 here. Okay, x plus 2 equals 0. How do I solve? And last one, I'm going to plus 2. So an answer 2, an answer of -2, and an answer of 0. Okay. Yes, sure. All right, so hopefully we're starting to figure out like how I'm working through the flow chart, trying to help ourselves out. Okay. What about 2C? Is this one equal to 0?
No.
Okay, what do I have to do to make it equal to 0? Add 50. Okay. Okay. So now it's equal to 0. How do I start the flow chart off with?
Great common factor.
Greatest common factor. Do I have the greatest common factor here?
No.
No, I don't. Okay, I know that I'm not going to have an x divided out of everything because this 50 does not have an x. I know I'm not going to have a number divided out of everything because I have a 1x cubed. So it's really easy just to say, hey, no. Okay, after there are no, I've determined there's no greatest common factor. What do I ask myself? How many terms do I have? 4. Now this one, if you want to check B over A is equal to D over C, you can, but we've already determined that if it's a no, we're not solving that kind of problem. That kind of tells us it's always going to be a yes, and that we're going to have to use the box method here, which is the same as grouping. So I'm going to set up my box method. Where's my negatives come out at? Knowing that I multiplied a positive. So knowing that I multiplied a positive, where am I going to have negatives at? Bottom left and top right, good. Okay, and now I just need to find that first place to get me started. And after that, you can piece the rest of it together. There's a place that we know what the greatest common factor is right off the bat.
There's an x. X squared.
Okay, where's the x and where's the x squared?
The x is on the top and the x squared is on the side.
Good. All right. So now what do I multiply x by to become negative 25x?
And top right, so.
So again, hopefully, like I mentioned at the beginning, yes, there are some new components to this lesson, but it's a lot of the same things that we've already been doing. So this is at worst a good review for you. Okay. How do I tell if I have to factor this again, or at least need to check if I have to factor it again? What do I look for? Like an x squared, and I have that. I have an x squared right here. How many terms is this? 2. So since I have 2 terms and I have an x squared, I need to check if that's a special pattern. So this is an example of one where I needed to go through the flowchart a second time. I need to see if it's in that a squared minus b squared form. Is x squared a perfect square?
Yes.
Is 25 a perfect square? And am I minusing? Yeah, so all 3 of those parts are met. This is a difference of squares pattern. What do I multiply by itself to get x squared? What do I multiply by itself to get 25? It's my A value. It's my B value. Okay, and so then what's this factor into?
By
Same pattern as 2B. Same pattern, just different numbers as 2B. X plus 5 and then X minus 5. Okay. Okay, everything's completely factored. I don't have like an X squared or anything like that. So now what I want to do is take each factor and set them equal to 0 and solve. Sure. Okay, notice I didn't really show my work solving all those. I mean, they're all one step. I feel like it's not necessary. If you want to show your work minus +2 on both sides, -5 on both sides, +5 on both sides, that's fine, but it's unnecessary. All right. Let's do 2D. Okay, 2x cubed plus 8x squared equals 10x. Again, not equal to 0. So what do I have to do to make it equal 0?
Minus no.
Okay. You want to be careful, make sure you write it in standard form. Okay. What's the first thing I ask myself? All right. The first thing I need to ask. Greatest common factor. Do I have a greatest common factor?
No.
2.
Two.
Okay. Is there a variable that can divide out of all the parts?
X squared.
Okay. X squared. Let's check. Here's x cubed. Here's x squared. And here's x. What's the most amount of x's I can take out of every group? 1. So what's the greatest common factor? 2, 2x. Okay, so 2 divided by 2 is 1. X cubed divided by x is what? Two divided by 2 is what? 1. X cubed divided by x is x squared. 8 divided by 2 is 4. X squared divided by x is x. Negative 10 divided by 2 is x divided by x is cancels out. Okay, so now what I want to do, I want to ask myself how many terms do I have inside the parentheses? 3. Is this a special pattern?
Yes.
Okay, is x squared a perfect square? Is 5 a perfect square though?
No.
No, so is this a special pattern? If the 5 is not a perfect square, it's the first and the last is the only things you need to check. I shouldn't say the only thing, but no, it's not. Okay, so then does my A value equal 1? What's my A value equal? My A value is 1, right? When I have, okay, when I have x squared plus 4x minus 5, This is a 1x squared, so my a value does equal 1. So what method of factoring do I use? Just regular x. 1 times -5 is -5. B value is 4.
One positive, one.
1 positive, 1 negative. Has to multiply to 5. Add to 4, it's going to be positive 5 and -1. Okay, so 2x is equal to 0. X plus 5 is equal to 0. And x minus 1 is equal to 0. You solve each of these. Divide by 2. Minus 5. Plus 1. So I get 3 answers: 0, -5, and +1. Okay, my experience is that each of these problems are going to take each year roughly 5-ish minutes at least to start. Okay, I mean, we spent a pretty good amount of time. So what we're going to do right now is just kind of pause the lesson. I'm going to have you work on monitoring progress 3 through 6. Okay, that's kind of all I want us to work on. Next class, we will start with those monitoring progress problems and then do the word problems and then give you plenty of time to practice. So now that we've gone over those problems, let's go ahead and go over the monitoring progress problems. So the first thing we're going to do when we look at number 3 is check whether there is a greatest common factor, because it's already set to 0. And there's a W that can be divided out of all 3 parts, because I have a W cubed here, a W squared here, and a W there. So there's a common W that can be divided out of all parts. I'm going to divide that. Okay. So upon dividing that W out, you're now going to ask yourself how many terms there are. Inside the parentheses, there's 3. When there's 3, I need to start by asking whether or not that's a special pattern. So it's a special pattern because the first term's a perfect square, the last term's a perfect square, and the middle part is -2 times A times B. So this is what we worked on in the previous section. -2 times W, and then this is 4 squared. So W to the second is W squared, 4 to the second is 16, and the middle is -2 times W times 4. So this is a special pattern where my A value is W and my B value is 4. So this factors into W times W minus 4 to the second power equals 0. Since it's factored all the way through, I can set each factor equal to 0. I don't have to do this one twice because it's going to be the same thing. So we have W equals 0 and W minus 4 is equal to 0. Plus 4 on both sides. W is equal to 4. Okay, that's your first one. Okay, monitoring progress 4, it's already set equal to 0. Greatest common factor, there's not a common number or variable that divides out of each of those, so there's no greatest common factor. So now, no greatest common factor, the next thing I'm going to do is check to how many terms there are. There's 4. And as I talked about, we could check the B over A and the D over C. They are going to be equal to each other, so this one I can box method. I'm going to have negatives in each of my corners, and now I can start taking greatest common factor out. This greatest common factor is going to be 9. This one's going to be 1. This is going to be 2y. And this is going to be y squared. So now what I have is 2y minus 1 times y squared minus 9. I do have a y squared. I have something to the second power. So I'm going to want to check this to see if it can be factored further. So what I have to do is go back through here. How many terms there are? There's 2. Since there's 2 terms, I want to check if it's in the form a squared minus b squared. And it is.
because I have a perfect square of y squared minus a second perfect square of 9. So this is in the form y squared minus 3 squared, where my a value is y and my b value is 3. So this is going to factor into 2y times y plus 3 times y minus 3. Okay, so now what I can do is, now that is completely factored, I set each of these equal to 0. Okay, with 2y minus 1 equals 0. I'm going to solve this one through because we haven't had a 2-step yet. Y is equal to 0.5. Okay, but the other ones are pretty easy. Y plus 3 equals 0. So that means y equals -3. Y minus 3 is equal to 0. That means y is equal to +3. So these are my 3 answers here. Okay. All right, number 5. Start where we always do, greatest common factor. Looks like there's an x to be divided out of each of those because I have an x cubed, which looks like this, and an x. So I can take out an x out of each group. And then I need to check here for special patterns because I took out the greatest common factor. How many terms? There's 2 terms. Got to see if it's in the form a squared minus b squared. So it is in the form a squared minus b squared, where I multiply x by itself to get x squared. I multiply 5 by itself to get 25, and I'm subtracting in between. I have an a value of x and a b value of 5. So this factors into x times x plus 5 times x minus 5. Okay, now that it's factored completely, I can set equal to 0. So x equals 0, x plus 5 equals 0, which means x is equal to -5. And then I have x minus 5 equals 0, which means x is equal to +5. Okay, on 6, it's not set equal to 0, so I have to start off with that by minusing 18x. 4x cubed minus 34x squared minus 18x. Okay, so now the first method in our flow chart says greatest common factor. Okay, so you do a little bit of work and you're going to find that a 2x divides out of all of those. Okay, 2x divides out of everything, so I'm left with 2x squared minus 17x minus 9 equals 0. Okay, after that, I take, I ask how many terms there are, and there's 3 terms. Then I check for special pattern, and I can say that this is not a special pattern because 9 is a perfect square and x squared is a perfect square, but 2 is not. 2 is not a perfect square, so that's not a special pattern. Is it a special pattern? No. Does my a value equal 1 here? No, because the a value equals 2. So this one is going to require the x and box method of factoring. So here I set up my x. A times c is -18. My b value is -17. Numbers that multiply to -18 and add to -17 are going to be -18 and +1. So I set up the box. I know I'm going to take a net 18 out there. And now I just got to start looking for greatest common factor. There's greatest common factor here of 18. And here would be 1. Here would be 2x. And here would be x. All right. So after you find that, then you can say 2x times 2x plus 1 times x minus 18 equals 0. And if you're struggling with any individual methods of factoring, you might just have to go back in the previous section to watch those videos. Okay, and so then here I can say 2x equals 0, which means x is equal to 0. Here 2x plus 1 is equal to 0, minus 1, divide by 2, x is equal to -1/2. Okay. And last, x minus 18 equals 0, which means x is +18. And those are all the answers. Okay, let's put this to use. All right. A terrarium in the shape of a rectangular prism has a volume of 4,608. The dimensions of the terrarium in terms of the width are shown. Find the length, width, and height. Okay, so here I know that we're talking about volume. So volume is going to be length times width times height. In this situation, the volume is 4,608. Looks like my length is 36 minus X. My width is X plus 4. And my height is X, I guess. It doesn't matter, they're all. Okay. So what can I do here? Well, what I'm going to need to do is that since I want to use the zero product property to solve, and it's equal to 4,608, I actually can't solve this unless it's set equal to 0. So I'm going to have to unfactor this minus 4,608 and kind of start fresh. So here I need the box method and multiply this out. So this will be 36 minus X. This will be X plus 4 minus X squared minus 4X. 36 times 4, not sure what that is off the top of my head. 144. Okay, so then here now I have 4,608 is equal to negative X squared plus 32X plus 144 and times X. So now I have to distribute this X. 4,608 is equal to negative X cubed plus 32X squared plus 144X. All right, so now I want to set this equal to 0. Rather than me minusing this onto this side, I want to keep this A value positive. So I'm going to subtract or add everything to the other side. So here I'm going to add X cubed. I'm going to minus 32X squared. And I'm going to minus 144X. Okay, so here I do want to check just to make sure I can use the box method, even though I know it's 4 terms. You follow the flow chart here. So I'm going to pull that up. But we are going to ultimately end on B over A equal to D over C, I believe. So as I look through this here, no greatest common factor. How many terms do I have? There's 4, so I want to check to see if I can do the B over A thing. So here B over A, 32 over 1, and then 4608 divided by negative 144. It's also 32. Okay, so this is going to be a box method. So we set this up, and this is going to be a tougher one because the numbers are bigger, but we should be able to piece together what we need. All right. So here you just have to, like I mentioned before, you just have to find that starting point and the rest will unravel itself. So here I got to find the greatest common factor. It looks like it's going to be X. So this is X. This has to be X squared. Okay, if this is X and this has to be negative 144. And then this has to be negative 32. Because X squared times 32 would be giving me that. So this is, and again, this is the power of just being able to find one. You can problem solve instead of finding the greatest common factor of all of those. So here I have X squared minus 144 times X minus 32. I have an X squared here, so I need to check whether that can be factored further, and it can. As you follow through the flow chart, you go into your 2 terms here. Perfect square minus the perfect square. Turns out X squared, the perfect square for 144 is a perfect square also. So you have an A value of X and a B value of 12. So this is going to factor in x plus 12 times x minus 12 times x minus 32 equals 0. Okay. So what I can do is I can set each of these equal to 0, x plus 12 equals 0, which means x is equal to negative 12. X minus 12 equals 0, which means x is equal to positive 12. And then I have x minus 32 is equal to 0, which means x is equal to 32. Okay. So now what we need to do is we should probably check, because we know that this one is not going to be the answer because it doesn't make sense to have a width of, but either of these are reasonable. Okay, so here what we can do is check 30 length 36 minus 32 times 32 times 32 plus 4. Okay, that is your 4,608, and it doesn't make any distance negative. Okay, and then here we can do 12. So here we can go 36 minus 12 times 12 times 12 plus 4. And you can see it gives me the same thing. And as I look through here, it doesn't give me any negative distances either. So actually in this problem here, we have two reasonable answers, and they could both be 32 or 12 or 32. Okay, so when you find your length, width, and height, just if I were you, I would just pick one. Here, I'm going to pick 12. So here my length would be equal to 36 minus 12, which would be 24. My width would be 12, and my height would be 12 plus 4, 16. So these are the actual answers. Make sure you're plugging in your values into the equation. I guess I should have used W instead of X, but it all works the same. Okay, and I believe either one of these should work because as you can see, when you plug them in, you're still going to get the same volume. It's just you're not going to really have a wrong one here because they're all going to result in it being positive. Okay, let's take a second, pause the video, and try number 7, monitoring progress number 7. Same setup, it just doesn't really have much of a situation. Okay, so here we have a rectangular prism, so that's kind of like a terrarium. So we have something like this, where we have a length, a width, and a height. Says the length is X, the width is X minus 1, and the height is X plus 9. And the volume is 72. So again, we have another volume problem, length times width times height. So the volume is 72, so 72 is equal to length X times width X minus 1 times height X plus 9. Again, I want to use the zero product property to solve this, so I can't have it equal to 72. Rather, I need to set it equal to 0. So X minus 1, X plus 9. Okay, I'm going faster through the multiplication. That's because we've kind of assumed that you know how to do this. So this is going to combine to 8x. So 72 is equal to x times x squared plus 8x minus 9. And then I need to distribute. Okay, this one, the a value is positive, so I can minus that 72 over. Okay, and then I can begin to factor. Here I have 4 terms. There's no greatest common factor. 8 over 1 is proportional to negative 72 over negative 9, so I can box method factor this also. Then you can start with your greatest common factor in each part. Okay, this here I knew 9 divided out of each of these, so that means this had to be positive 8. If this is -9, this has to be x. If this is x, this has to be x squared. Then this can be factored further. As it's a two-term polynomial that does follow the difference of squares pattern. So I have an a value of x and a b value of 3. Where, because x times x is x squared and 3 times 3 is 9. So this factors into x plus 3 times x minus 3 times x plus 8. Okay, so you set each of these equal to 0 and solve. X plus 3 is 0, so x has to be -3. This can't be my answer because I'm not going to be able to have a negative distance here. Okay, then I go x minus 3 equals 0. So that means x is +3. Could be my answer. I'm going to have to check. And x plus 8 is equal to 0. So -8, x equals -8. And again, this one can't be my answer because I can't have a negative distance here. So here, what's my length? My length is equal to just x. So my length is 3. My width is going to be x minus 2. So 3 minus 2 is 2. And my height is going to be x plus 9. Since x is 3, 3 plus 9 is 12. Okay, and we should be able to check and multiply those numbers together to get a volume of 72. 3 times 2 times 12, 72. So that's the answer. All right, go ahead and work on your practice problems and progress towards the learning target and test.